Hello everyone, I'm Curtis Mayberry with Cascode Labs. Today I'm going to present the Viper Analog Design Environment. Recently, open source IC design has enabled small teams and individuals to tape out custom integrated circuits. This opens more hardware designs to improvements in size, cost, and performance by using custom ICs. This has been enabled by improvements in EDA tools, open source PDKs that don't require an NDA, affordable manufacturing that can be as low as just a few $100s. And today, there's still two main challenges: enabling workspace setup for distributed development in the cloud, and open source analog IP availability. Viper Analog Design Environment addresses the EDA environment problem by allowing any repository containing analog IP to immediately start a development environment that includes all the tools and they need to simulate and design custom circuits. It also enables process-independent sim workspaces and test benches that allow you to simulate an IP block over multiple processes within one VS Code session. So I'll show you guys how this works here. So there's a dev-container.json that defines or points to a Docker container that has all the tools pre-installed. It also allows you to install additional tools and allows you to use the desktop light feature to open desktop tool or graphical applications in a browser. So this, for example, if I bring this up, I can show you. Here's an Xscheme schematic that you can edit in a browser, and so it's a remote desktop from that running dev container. And then it also enables process-independent workspace where you can have a Bangap in Sky 130 or GF 180. You can work on them together in the same work area, and you can also simulate them in the same work area and run the same set of process-independent test benches on both designs. So those test benches are defined in software, so you can define a test fixture that netlists and runs a simulation once, and then you can run multiple tests on those, PyTest tests on those. And you can and then you define the test bench using a hardware description library called HDL21, where you define a simple Python class or function. You can do it either way, that defines the test bench. That includes the sources, top level signals, and the define what DUT you're going to bring in and the connections between them, and the simulation analyses and setup. So in conclusion, the Viper Analog Design Environment both allows you to instantly start designing and simulating an IP block that's on GitHub, and it also allows you to have a process-independent workspace and test benches so you can design multiple IP blocks at the same time in multiple processes.